Alright chaps, so I'm not here and I'm making a very quick video just so you know how to do these questions. And the first thing I'm going to do is turn my calculator on. Lovely. Alright, so we have two heat questions here. How much heat is required to melt 0.6 kilograms of ice? Now, I want you to remember there's two equations we can play with. We have got the first one, which is Q is equal to mc delta T. Where if you remember, Q is equal to the heat, M is equal to the mass, C is equal to the specific heat, and T, delta T, is equal to the change in temperature. So this is the equation we use when we're changing the temperature of something. We also have the other equation, which is Q is equal to M times the heat of fusion or vaporization. This is what we're doing when we're not changing the temperature of something, but we're just changing the state of it. So if we're going from a solid to a liquid, or a liquid to a solid, or a solid to a gas, or a gas to a solid. Wait, solid or a liquid? Liquid or solid? Liquid to gas, gas to liquid. That makes more sense. Yes, good. So how much heat of ice is required to melt 0.6 kilograms of... How much heat is required to melt 0.6 kilograms of ice? The equation we're going to, the first hardest thing is figuring out which equation we need. We're melting it. We're not changing the temperature of it, so we're going to need this first equation, which is Q is equal to mass times the heat of fusion or vaporization. So the next hardest thing is figuring out which of these two numbers do I need, right? So we have the heat of fusion of water, heat of vaporization. The question is, am I fusing the water or vaporizing it? So again, I'm going to grab a pen, make it a bit more colorful. Heat of fusion. Fusion is when you're going from a liquid to a solid. But it can go either way, right? If you're going from a liquid to a solid, solid to a liquid, the number's the same. It's just you add heat or take heat away. For the heat of vaporization, you're going from a liquid to a gas. So, again, vaporization, you think vapor, right? Vapor is a gas, whereas fusion, it's fused together, it's a solid. So, in this case, I'm actually going to want the heat of fusion because although I'm going from a liquid to a solid, I'm not going to a gas, it has to be this one. So, I use the heat of fusion. So, all I've got to do is plug it in. Q is equal to mass, well, actually, let's put in the actual mass. The mass, which is 0.6 kilograms. 0.6 kilograms multiplied by the heat of fusion, and this is on the worksheet you're going to pick up, is 3.33 times 10 to the power of 5 joules per kilogram. Kilograms cancel out, that leaves me joules, and you get a number. Let's crack out the old calculator. I got 0.6 times 3.33 E5, and I get an answer of 199,800 joules. That is question 1. Alright, so question 2 is this one. How much heat is required to change the temperature of 0.6 kilograms of ice at negative 10 degrees to water at 20 degrees? So this is where we got to think about what we're doing. We're doing three different things. The first thing we are doing is, it's an easy problem, but there's just 3 steps to it. Because the first thing we're doing is we got ice at negative 20, so that's like here. And we have to heat up this ice until it becomes a solid at 0 degrees. So this is phase 1. Then, when it's a solid at 0 degrees, we have to pump a load of heat into it to melt it, turn it into a liquid. That's phase 2. And once it's a liquid, I can heat it up to, oh, that's supposed to be negative 10. Either way. I can heat it up to 20 degrees. So there's 3 steps. The first one is warming the ice. The next one is melting the ice, and then the third step is heating water. So, let's do this. Oh crap, it lit. That's fine. Never mind. Right, so if you remember, step number 1 is warming ice so it becomes 0 degrees. So again, you have the 2 equations. Q is equal to mc delta T, or mass times the heat of fusion. I want the first equation because I'm changing the temperature. So it's going to be Q is equal to mc delta T. The mass is 0.6 The C, I need the C. Now, that's a great question. If you look at the worksheet I gave you the C of ice, C of steam, C of water. Just look at the top, it'll tell you the C of ice is 2108 joules per kilogram degrees Celsius. And then we need the change in temperature. I'm going from -10 to 0, so the change in temperature is 10. And that will give you a number. Let's figure it out real quick. 0.6 times 2108 times 10 equals 12648. So this equals 12648 joules. Alright, part 2. We got to melt the ice. Now, believe it or not, I am very lazy. And to melt the ice, I need to do Q is equal to mass times the heat of fusion or vaporization. Again, it's ice, it's solid, so it's going to be the heat of fusion. This is the exact question we just did, because, again, very lazy. So the answer to this bit is 199, because I got the exact same mass, 199,800 joules. And then the third bit is, now I got the ice, it was solid. I pumped in a load of heat, this much heat, and it's turned into a liquid, but it's still 0 degrees Celsius. Now I need to warm the water, because it's water now. Warm the water. So again, changing the temperature of the water, I need the first equation, Q is equal to mc delta T. So it's going to be 0.6 times the C of water. That's different to the C of ice. The C of ice is 2108. The C of water you'll see in that worksheet is 4186 joules per kilogram degrees Celsius, multiplied by, I'm now going from 0 degrees Celsius to 20 degrees Celsius. So the delta T is going to equal 20. So multiply it by 20. And you plug all that in. Give me 1 sec. 0.6 times 4186 times 20 equals 50232. 50232 joules. So we're done. We're not done. That is a lie, because there was 3 steps to the heating up the ice, right? Warming the ice, melting the ice, warming the water. So now we just got to add these together. So it's going to be 50232 plus the 199,800 plus the 1264648, and it's going to be equals 26268 joules. And that's it. Easy as that. Alright, so that's the example problems. The worksheets at the back. Have the stab at it as best as you can, and if not, I'll speak to you tomorrow. Alright, cheers. Bye.